Hello everyone, this is Anita and my friends Durga, Anita, Anupriya and Bharati. We are from RMD Engineering College and I'm thrilled to be part of this Jigsaw teaching method with my fellow friends. And we were fortunate to receive this wonderful opportunity from Rajalakshmi ma'am, a faculty staff in our college. She really helped us with implementing this Jigsaw teaching method. And let's give a big thanks to our ma'am. So today we are going to explore a fascinating topic in graph theory called a multi-stage graph problem. Imagine if you are having a problem where you need to take decisions at different stages and each decisions will affect the overall outcome. So a multi-stage graph will help you to visualize and analyze this kind of problem. Let's get into the definition of multi-stage graph. A multi-stage graph is a directed, weighted graph in which the nodes can be divided into set of stages. And all the edges connect the nodes from one stage to the next stage only. That is, there are no edges between the vertices within the same stage or from a vertex in a current stage to the previous stage. And the main goal is to find the shortest path from the source node to the destination node in the given multi-stage graph. It's like having a roadmap to guide through a decision-making process. And we consider the stage 1 as source node and the destination as the last stage. And we solve this multi-stage graph problem by following a dynamic programming approach. It is invented in 1950 by Richard Bellman, an US mathematician, as a general method for optimizing multi-stage decision processes. It is a planning concept in which technique for solving problems with overlapping subproblems. It involves breaking down a complex problem into smaller ones and overlapping the subproblems and solving them in a systematic manner. And we can take this graph as multi-stage graph. You can see in the starting stage 1, there is only one node which is known as the source node, and in the last stage there is also only one node, node 12, marked as T. So we need to go from the source node to destination node, and there are n number of paths to reach there, but we need to find the minimum cost path to reach the destination node. So the nodes can be divided into multiple stages. This graph consists of 5 stages, and we need to find the minimum cost path from S to node T. It can be done in 2 ways, forward approach and backward approach. In forward approach, we use this equation to find the minimum cost. That is cost of I comma j. Here I represents the stage number in which stage we are doing, and the j represents the vertex, which node in that stage we are doing. So it means the cost of jth vertex in the ith stage. That is equal to minimum of C of j comma L plus cost of I plus 1 comma L. Here L represents the vertex in the last stage. And for the backward approach, it is the same, but for C of j comma L, we write here as L comma j, and B cost of I minus 1 comma L. To find the minimum cost using forward approach, we find from the last stage. That is, we calculate the minimum cost to reach the 5th stage node, destination node, from the 4th stage, and then to the 3rd stage, 2nd stage, and we reach the source node. And for the backward approach, we come from the first source node, 1st stage, 2nd stage, to the last stage. and you are 4, you can divide into 2 teams to solve each approach team wise. You can divide among yourself.
Okay. Myself and Bharati will go with forward approach.
Okay. And Durga Nanu, you will do backward approach.
Okay.
If you have any doubt, you can ask. I'll give you 2 minutes to solve. Solve. Completed?
Yes.
Yes, explain forward approach method. You and Bharati. Bharati, you can proceed.
Second round. Okay, as we see in forward approach, we will be going from the destination to the source. In the stage 5, the vertex number is 12. The cost will be zero because the initial cost is 0. There is no path coming to 12. That's why we consider it as 0. To go with the stage 4, we have 3 vertices, that is 9, 10, and 11. For calculating the value for stage 4 ninth vertex, the cost would be 4 added with the cost with the previous vertex. That is, initially we considered as 0, right? That's what that value will be added. So the value will be 4. For that vertex, the value would be 4. For ninth vertex, the cost would be 4. Similarly, we will do it for the 10th vertex. Same way, if we add the cost 2 with the previous cost 0, the value would be 2. And similarly, for the 11th vertex, the value will be 5. On comparing these 3 values, we will select vertex 10 because the total cost came is 2, which is minimum cost compared with other 2 vertices. Now, stage 3 will be explained by Bharati.
In the similar way, we can find the stage 3 also. In stage 3, 3 nodes there, and 6 and 7 and 8. First, we have to find the cost of 3, 6. First, you have to compare this formula, minimum of C of j, L plus cost of I plus 1, L. Apply this formula and 3, 6, the cost will be 10 and 7. 10 is the last node is 9. Then the cost of minimum is 10. Then the last node we can take 10 and then the cost of 7. We also compare this 10 and 7. We take minimum value. This is the cost of 3, 6. Then we have to come similar way. We have to find all these nodes. Cost of 3, 7 and cost of 3, 8.
Okay. Similarly, we will be calculating for stage 2. Stage 2, we have 4 vertices. which is 2, 3, 4, and 5. As Bharati explained, using the formula, we will be finding the cost for 2, 2, but that is stage 2, vertex 2. The cost would be 7, and for the vertex 3, the cost would be 9, and for the vertex 4, the cost would be 18, and for vertex 5, the cost would be 15. On the whole, we will select the vertex which has the minimum cost. That is vertex 2, which has the lowest cost, 7. Similarly, for stage 1, while we calculating, the cost would be 16. So it would be coming as 16. But then we have to select the path. So how we will select is, as we compared the values and selected the minimum values, right? By the way, we will do like that. D of 1, 1, that is stage 1, vertex 1. The cost was 2. That cost would be the vertex number of the second stage. That is 2, 2. The value would be 7, and in stage 3, 7th vertex, the value would be 10. In stage 4, 10th vertex, the value would be 12. So the path would be 1 to 2, 2 to 3, 3 to 7, and 7 to 12. So this is the minimum cost path for the forward approach. We found answer.
1 to 2, 2 to 7, 7 to 10, and 12.
10 to 12. Yeah.
And for the backward approach?
In backward approach, we have to take node 1 as start. So from node 1, we are going to find the path. Here we have to find two cases. One, the weight of the node, and what is the previous node. In first state, there is only one node. There is no incoming edge. So we can easily find the cost of the node 1 as 0. In the stage 2, there are 4 nodes, 2, 3, 4, and 5. When we taking node 2, there is only one edge coming from node 1. The cost of the node 1 is 0, and the edge length is 9. So 0 plus 9 is the cost of the node 2, and the previous node is we can take 1 because there is no other edge coming to 2. So similarly for 3, the cost is 7 and the previous node is 1. For 4, the cost is 3 and the previous node is 1. For 5, this is 2 and the previous node is 1. Stage 3, Anu will explain.
In third stage, we have 3 vertices, 6, 7, and 8. And let's consider for the vertex 6. For the vertex 6, we have 2 incoming edges. Like we have 2 and 3. So we'll be comparing, like we'll be summing up the cost of that last node with the path length. So let's consider number 2, which is the vertex 2. So the cost of vertex 2 is 9. We are adding that with the edge length, which is 4, which is going to be 13. And when we consider vertex 3, its cost is 7 and its path length is 2. 7 plus 2 is 9. Between these two values, 9 is going to be the minimum, and that is going to be the cost of the vertex 6. And that we got from the node number 3. And similarly for the vertex 7 and 8, we'll be finding the same. For the vertex 7, we have 3 incoming paths. So that is from 2, 3, and 5. For the vertex 2, like when we consider vertex 2, the cost of vertex 2 is 9. That we're adding it with the path length of 2. So 9 plus 2 is 11. And for the vertex 3, its cost is 7. We're adding with the path length 7. This is going to be 14. And when we consider vertex 5, its cost is 2 and path length is 11. Summing up, we get 13. Among these 3 values, we get 11 as the minimum value. That is from the node 2. And when we consider node number 8, we have 3 incoming paths, that is from 2, 4, and 5. When we consider vertex 2, we have the cost as 9 and path length as 1. So 9 plus 1, 10. And the next vertex we consider is 4. Its cost is 3 and its path length is 11. Summing up, we get 14. Similarly, for the vertex 5, its cost is 2 and path length is 8. Summing up, we get 10. Among these three values, we get 10 as the lowest value. That is going to be the cost of the vertex 8. That too we get from the vertex number 5. That's going to be the cost of each vertices of stage 3. And stage 4 cost will be found by Gupta.
In stage 4, we have 3 nodes, 9, 10 and 11. When we look for 9, there are 2 edges coming from 6 and 7. So the cost of the 6 is 9 and the edge length is 6. So totally 15. And for 7, the cost of 7 is 11 plus the edge length is 4. So it is 15. The values both are same. If the both values are same, we can take any node. In this case, we are taking the previous node as 6. When we go for 10, there is 3 edges coming from 6, 7 and 8. For 6, the cost of the 6 is 9 plus the edge length 5 is 14. And then for 7, the cost of the 7 is 11 plus the edge length 3 is 14, again 14. And from 8, the cost of the 8 is 10 plus the edge length 5, 15. So here also we have minimum value 14 for 2 cases. So we can take 6 as the previous node for 10 also. When we move on to level, there is only one edge from 8. The cost of the 8 is 10 plus the edge length 6. So the cost of 11 is 16 and the previous node is 8. Anu will tell for node 12.
Yeah, when we consider stage number 5, we have only one vertex, which is 12. And we have 3 incoming nodes for 12, that is to 9, 10, and 11. When we go to 9, its cost is 15 plus the path length is 4. So 15 plus 4 is 19. And we go for 10, its cost is 14 plus the path value 2. Summing up, we get 16. And for vertex 11, its cost is 16 plus the path length is 5. And summing up, we get 21. Among these 3 values, we get 16 as the lowest value. So that's going to be the cost of vertex 12. And that lowest value we get from the vertex number 10, from the last node 10. So the shortest path will be found by Durga.
To find the path, we have to check the previous node from 12 to 1. So when we check for the previous node of 12, it is 10. So and then we check for the previous node of 10 is 6 because it has the lowest value. In the same way, when we look, the previous node of 6 is 3 and 3 is 1. So the path for backward is 1 to 3 to 6 to 10 and to 12.
So we found two solutions. Both are same cost. We can choose any one solutions. The first one is using forward. We got this 2 to 1 to 2 to 7, 10 and 12. And by backward approach, you found 1 to 3 to 6 and 10 to 12. So the cost will be the minimum path cost will be 16,
16.
right? 16. Okay. So based on the analysis of multi-stage graph, we can see that the optimal decision path is to follow the specific nodes and edges that leads to the desired outcome. And this graph provides a clear visualization of decision making process, allowing us to make informed choices. We get to know that which choice we are making. So it provides informed choices and well done on navigating through this complex problem with the help of the multi-stage graph problem. If you guys have any doubt, you can ask me.
No doubt, sir.
No doubt, sir.
Thanks everyone. I appreciate your participation and contribution. It was a fascinating session. Thank you.
Thank you.
Thank you.